student satellite program for empowerment of innovators and incubation of startup in space, which is very essential. How we can able to move on to the startup and how so because the more startup, another couple of years, you all know that how our chief guest in the morning suggested that we has to be superpower. The same like that empowering with nano satellite with examples. So, particularly sir mentioned in the practical example. Very impressed that with that we are initiating the first session. I would like to introduce our first speaker today, Shri GNV Prashad, former Deputy Director, ISRO Satellite Center, URSC, Bengaluru. GNV Prashad, former Deputy Director at ISRO, joined in 1984, specialized in servo control and electrical machines, contributing to indigenous development of DC servo motor and drive systems. Collaborated with Russian on ground support for GSM. At URSC, focused on PCB development in 2013, then LED system engineering group, establishing advanced electronic fabrication facilities. Later, served as group director for program planning and evaluation, overseeing satellite program management and infrastructure planning. He was promoted to deputy director, managing information system and supporting overall center requirements. He awarded the ASI award in 2014 for spacecraft technologies, superannuated in 2018 after 34 years of service. Currently a professor of practice at Dayan Sagar University, Bangalore, and providing consultancy to SS Innovations, Delhi, on surgery robot electronic manufacturing. We are very happy to invite Sir Sri GNV Prashad to present his presentation on student satellite program for empowerment of innovators and incubation of startups in space.
Good afternoon to all of you.
Good afternoon, sir.
Good afternoon, sir. So my job has been made slightly difficult because it is just after lunch. I have to keep awake as well as see that some useful information I share with you people. Once again, good afternoon to all of you, and thank you, sir, for your nice introduction. And it's indeed my great privilege to be part of this event. And I saw morning session how hectic it was, and somehow it went on well with our Vishwamitra like Dr. Vaskam sir, Dr. Shudan Pillai sir, and Dr. Vishwanath sir took a lot of initiatives and things. And our arrangements also have been made very nicely. In fact, I should say Gunshekhanum sir was constantly following our things. So with all this, the morning session went off very well. And we had a lot of information about the overview of ISRO itself through Dr. V. Narayan's presentation. So with this, I will not take much of time because already I am trying to compress within 20 minutes or so. Kindly excuse me if I am trying to run through even my slides also. But I will try to give useful information definitely. And I am sure that all of you must be tracking the development and progress, what is happening in the space sector. Am I right? So definitely, because in recent few years, you may be seeing a lot of news related to space. So definitely, all of you will be definitely tracking those things. And another point what I would like to say is, space industry is a unique industry where beyond this commercial, there is a lot of possibilities, or it is a fascinating thing where you will have possibilities of innovations and explorations. See, which is the opportunity which we get in this space sector. And today's government policies, framework, and privatization, private industries participation, and also ISRO, which has developed a very robust and vibrant space ecosystem, definitely will empower entrepreneurs and startups to do a lot of innovation activities and also explore the space technology related field. So with this, the most important tips for any space startup is, if you want to become a successful startup in space, you should have patience, you should have perseverance, you should have passion. More than this, you should also have passion, and you should be ready to face any failures. That's what the earlier speakers also were told. So these are the four things which we need to follow if we have to become a successful startups or entrepreneurs in space field. Because ISRO, if you see, many failures have happened, many hard things we underwent during, of course, sir days are still, it was hard, and our days I have seen a lot of failures during SLV and all, it was humiliation also. And even when we went to mainland, that is Sulanpet from Sriharikota, they have thrown stones at our bus. These are the humiliations which we have faced during 83, 84 and all, when SLV's failure, and lot of fun people were making that sea launching vehicle, assured sea launching vehicle, like that, love vehicle, like that. So all such things we have undergone, but still with our great leaders who have built this ISRO, and with a lot of dedicated workforce and dedicated passion manpower, where we were not bothered about the timings. Timings were not there for us. If we have to work, we can work anytime we can go to office, anytime we can be in office. That was the culture which was inculcated by all our seniors. And today we have a living legend, Dr. R.M. Vasakam sir, who are all inspiration and motivation for all of us. And I will start my session with these few words. So, right now what I am doing is, I am a professor in Dayanand Sagar University, where we have started hello. Right now I am in Dayanand Sagar University. It's campus 3, innovation campus. It is called as innovation campus. We have started a Center for Space Science and Technology. It is a separate cell, and where we have started the students' satellite program with a lot of takeaways for university, students, faculty, and for societal applications. So now I will present how this student satellite program helps in empowering innovators and also incubation of startups in space. How do we do that? Now, as we know, satellite is not confined to any of this organization or anything now. It has become a name of household name today and familiar with irrespective what is the education qualification or whatever may be the thing. So such a thing has happened. And what is the best way of empowering innovators and startups in space is to bring space education revolution in universities, colleges, which are more important, what we felt, because already some industries which are in this space, they have saturated or they are not able to take up all such like innovations or empowering the startups things and all, because they have their own activities which are being streamlined. So only universities can see that the space education can be introduced at the students' level itself, which will definitely make students trigger their minds towards the innovation and also entrepreneur culture. So space education becomes paramount importance, not only nurturing the second generation of scientists and engineers, but also for instilling critical thinking and multidisciplinary collaboration, because while multidisciplinary is, as Dr. Narayan told, and even Dr. Sriram Pillai also told, because all branches of engineering, science are involved. So here also what we have seen in many universities, what ECE department does, mechanical department is not doing, or what aerospace department does. So here what stress they have given to us is stressed upon. The management has told that all faculties and all students have to be trained in handling the multidisciplinary activities, and they should be formed as a team leader for project management and to execute a project. Even faculties, they should exchange views among their own branches and with the different branches. And if they come out in a collaborative way, definitely we will be able to produce the product. And I will come back to those slides where we are working with different startups also, where we are involving faculty as well as students. So here what happens is all these things will enable the application-oriented mindset from a global perspective, and it also facilitate a profound understanding of our planet's place in the universe. So the significance of space education extends beyond conventional classrooms and textbooks, offering activity-based experimental for maximizing the learning outcomes. What we have done is, in addition to theoretical aspects of space technology, we also have introduced classroom models, satellites, ground stations, CAN-SATs, hackathons programs, practical challenges in the space with small satellites, so that it can be done at a cheaper cost and easily understand, affordable for university also. So all these things have been taken into consideration and we have found those activities. And in an era increasingly dominated by this technology, space education cultivates invaluable skills, because we will be handling multidisciplinary activities. And this is very essential for modern workforce, and this helps in capacity building for our nation's space programs. And especially problem solving, what we have seen is, in ISRO, we have a technique called lessons learned from failures. Those things have been documented and they review extensively. These things will help us next time when we take up any mission. Those lessons learned will be taken care and the design will be done as per whatever required things, so that we will not be doing the same mistake in the next subsequent missions. So such things also we will be able to learn, which is very essential for any startup or entrepreneurs in this particular space activities. And also space education equips students with knowledge and skills relevant to wide array of careers in the fields of oceanography, geology, deep space explorations. Material science is another important thing, because many materials we are importing, we should see how it should be made within India itself, so that we can cut down further costs. And we also can do importing. There only we are lacking. We see always from the numbers point of view. What we see in Indian industries, they always ask how many, what is going to be quantity. In space, there is no term like quantity or something. It is a quality based and reliability. They are two important things. But industries in India have been tuned in such a way that always they look upon what will be the quantities have been built. So that's why I told you, ISRO has built very robust and vibrant space ecosystem, not only in satellite, even in vehicle integration, vehicle development, testing of those motors. In all the areas, if you see, ISRO has built a wonderful space ecosystem, which is definitely a boon for all our young innovators in this space field and entrepreneurs. They can utilize these facilities through InSpace and NSIL, which has been created by the Government of India to facilitate coordination between ISRO and startups. So students' satellite program in universities play a very important role in creating innovators and transform them as an entrepreneur. Further, it also helps to start their own startup in space sector. As we told, some 3-4 startups which we were guiding, they are doing very well in the satellite technology area. They have come out with very novel ideas in deployment of antenna mechanisms. And of course, many ex-ISRO people were guiding them, and today they are doing very well in those areas. So likewise, we also see many of you should come out as a space startups and entrepreneurs in this particular field. And student satellite program in university facilitate kindling of minds of students in science, technology, engineering and maths. And student satellite program in university is introduced by introducing course in space technology, and also practical aspects of space technology is being taught, and hackathon seminars also have been conducted to see that we have inter-university or inter-college exchange of views. Because when students get exposed to the other colleges, what they have done and other things, they learn more and it becomes competitive spirits. They come out with the novel ideas and all. And I would like to say that 5 papers of our space, whatever we selected students for our space technology activities, has been accepted in Goa seminar. And 1 paper has been accepted in our BSSC for related to this student satellite program only. And 5 papers for Goa space seminar thing has been accepted. Likewise, we are trying to see how best we can charge the students in this field, and also faculty also we are trying to bring them together. Today one of the faculty is working on digital twinning payload, which we are going to test on the POEM platform. The student satellite program is enabled in engineering colleges and university, establishing by Center for Space Science. This is what I told you. CSST we have established. It's a dedicated department on cell, we can say. Dr. R. Vasanam sir inaugurated that facility. That facility comprises of a clean room where we nurture give a real feel for students how the clean room things, how clean room culture has to be developed. All such aspects are taught. It's not just clean room like clean, but it requires, the students requires to know how he has to follow certain things in the clean room, and then how he has to perform his activities within the clean room. All such things, if he inculcate at this stage itself, definitely he will be much better when he comes out and start his own startups. Or even some startups, they can work in our own clean room and utilize our facility also. That provision also has been made by the university management. And we have introduced a subject called space technology for aerospace 7th semester, and we also have introduced as an open elective for 6th semester ECE mechanical and computer science students, and we also have introduced antenna microwave course, because we have one former director of ISTAC who was communication person who has introduced that course, and he has trained the faculty. And another important thing what we thought is to train the trainers. Means faculty should be trained first or along with the students itself. So the faculty will continue the activities which we were doing for students, and definitely the whole program will sustain for a very long time. And we have established a necessary infrastructure required to do all practical aspects of satellite technology and to make the students to understand overall satellite system. And these are the photographs of some of the photographs of the clean rooms where you can see this is a clean room where you can see many of the tests. Like your drone also, one of the students is working on 8 drone related things to see for our CANSAT launching and other activities. We also had a talk from Dr. sir also. He has given a very good payload idea also from the medical point of view, how we can help the doctors. Because Diane sir also is having a medical college and a hospital, and he wanted to see that doctors and we coordinate each other and come out with a novel payload idea like malaria detection or any other related things where a satellite or a drone, initially it can be for some particular area where drone also can do the mapping. So only thing is we would like to qualify the payload. Once it is done, putting it in a satellite is not a very big thing. So that idea also has been given by him. And in fact, one more idea was given for Puneet Rajkumar satellite. That when satellite passes over our Bangalore pass, Puneet Rajkumar's sound should be heard. So that will make the satellite, whatever purpose of the satellite made. That was the idea of Sir only. So you can imagine he is such a senior person, but he is able to think and definitely our youngsters will have much more ideas and much more thinking should come. Only you stop using mobile less and then start thinking on your own. So definitely you all will come out with much more ideas. So these are some of the photographs. Can you see? So this is of course 1 lakh class clean room. That means the particles level of 0.5 microns, 1 lakh is allowed, and temperature is about 22 plus minus 2 degrees, and humidity we maintain at 55 plus minus 5%. Similar to that of a very huge clean room, what is established already in our URSC or anywhere else. and we have all these ESD flooring, ESD work table, so that students get trained in all aspects of handling the flight hardware. That is our intention. And he should wear apparels, clean room apparels, that whatever chappals are there, he has to enter through air shower. All these aspects he will come to know, and which he need not establish at his place, because any startups, they will have finance, funding will be the main problem. So instead of establishing such clean rooms, we are welcoming startups to do their own works at our place, and they can do their activities and prove their whatever ideas they have got. So such things also have been planned here. And we have established a ground station to track students' satellite and as well as weather satellites, and to get familiarized with the mission control, tracking and telemetry data analysis. And these are some of the screenshots. These are some of the screenshots which have been taken. So the main objectives of CSST already I told you, that we would like to make the university as a leading university in space technology, and also it will become a center for excellence in the design of space. And we also see that students contribute in the through research and development programs in the national space programs, and also last but not least, to help and handhold the students to build up startup culture for new generations of innovators, student entrepreneurs to start space startups. So these are the CANSAT programs which we started, and students very enthusiastically involved in these programs. And these were our hackathon related activities. And these are some of the subsystems, because CANSAT is one which is a challenging thing for students, where they need to build a satellite, full satellite within the CAN size. And they will be knowing about all the subsystems, ODC, EPS, electrical power system, communication, payload, ground station, and all the activities like making structure. So some students have come out with a 3D printing structure itself. Some students have come out innovative idea of antenna related things. So many things have happened in this particular field. Later on, what we have done is we have introduced CubeSat, classroom CubeSat models, where we have planned two 1U CubeSat. This is mainly, one is as if CubeSat is in space, and they will be tracking same CubeSat in the second room, the other room, in the same ground station. So they get tracking of the satellite, as well as the feel of tracking the satellite, as well as the ground station operation. The another aspect was the two satellites are there, so we were able to test the intercommunication. That is the one which is required now, because a lot of constellation of satellites are being planned for internet services and other things. And these are some of the payload ideas for students. It will be beneficial for startups who can think of Internet of Things in space, inter-satellite communication, GPS related applications, messaging from one station to another station, internet applications, fish harvesting guidance, like morning it was told, then fisherman tracking and communication. That is also one of the important things where we can avoid some disaster about fishermen crossing over the borders, water quality monitoring, then air quality monitoring, unmanned railway crossing. We thought we will introduce in some small villages where even animals should not get killed by the trains. So then cargo tracking like ATM cash loading van, whatever we have seen many news we will be hearing that ATM vans have been taken away by the driver and cash is stolen, and such things can be avoided. And thermal infrared hyperspectral camera payloads for of course 3U and 6U satellites we are planning, and adaptive electro-optics payload for Earth observation. Spacecraft reorbiting. Like morning it was told, lot of debris have been accumulated in the low Earth orbit that need to be cleaned up. That has to be planned. So we are just planning a small payload in our CubeSat where it can, after 6 months or so, it is supposed to trigger the deorbiting thing and start coming down by itself and gets destroyed. Such things also is being planned. And one of the students has come out with idea where we thought we created the idea. So that I don't want to right now say, but about for same for debris later. And these are the areas where students can, startups and these students can definitely work on this. Payloads, satellites, launchers, landers, small satellites, satellite IoT, already I have covered. Advanced ground station, this is also one of the important areas where students can think of. Then artificial intelligence, AI, applying AI. And I just want to share you the idea that in URSC, what we have done is we use thousands of solar cells in the panel to build the solar panel, which is with a primary source of power for satellite. And the solar cell, when it is bonded, even the smallest crack human being cannot find out during inspection or anything. So what we have done is we have adapted AI technology to inspect the panel, and successfully it has been implemented where even a minute scratch or anything also it can detect and we can change the solar cell. To that extent AI has been placed, and similar applications can be thought of in different areas also. That's why I just shared you that idea. And advanced satellite constellation, which is the need of the hour, and next generation satellite communication systems. You all must be knowing about LoRa. LoRa communication is a very, very important, and that is going to be in future, where even ISRO also have not right now. But probably you people should be first in utilizing it for both communication with the ground station as well as the intersatellite communication, where it has a long range as well as high noise stability. So in that line also you can think and make a communication system. A prototype is enough in the lab, and those things can be brought to us and we can qualify it, and we can see a better transport system for testing those payloads. And some of the concentration, just one slide only. These are the consulting areas where we provide. Though we belong to university, we also try to see that we give our expertise through university for center electronics, clean room facility augmentation, for L&T aerospace master plan document for spacecraft integration and test establishment has been made, and transect satellite technologies, payloads and mainframes, we are helping them. And RF nano composites is one of the startups who have come out with a coating where EMI and EMC things can be minimized, because now we use very high value space components. With just coating of this, we can avoid those utilization of those components, high value components, and we can go for a lower means parts component can be coated with this and it can be upgraded for space use. And that activity is going on at RF nano composites. Alpha design technology also, where we have involved in clean room related. And one more space startup, Wellens space startup company has come up. They want to do microbiology lab related testing, and we have interacted with them for 2-3 sessions, and we have planned that payload to be flown on the Poem platform. point platform is nothing but PSLV 4th stage is going to be given for academic purpose, university satellites or university payloads and all, where we can test our payloads without much of tension of launch or any satellite building or anything. See, that is very critical. Once our payload is qualified and it is space flown heritage, then we can confident that we can give to a satellite person where he will integrate with their satellite and launch. So that is the plan what we have made. And these are all the takeaways which I told you already for faculty, for society, for university, and especially for students. They all will come to know about satellite at the early stage itself, where Dr. Narayan very rightly told, during our school days or college days, we have not heard about space related programs at all. Even I studied in PhD Tech Coimbatore, we had not heard. When I got a call, interview call, then I was wondering how electrical machine person is useful for space. That was my doubt. So when I went for interview at Indian Institute of Science in 83 or so, then I was really thrilled and fascinated to see that space is a multidisciplinary thing. It is not that you belong to electrical or you belong to electronics or you belong to mechanical or whatever maybe, but all have to work together. See, unless we work, we share our activities, definitely we cannot succeed in these space areas. And that's what he insisted, that all faculty members, all the collaborating mode of working is very, very important here. Then only we can succeed. With this, I wish all the best and good takeaway for all these participants in this for this space empowerment whatever seminar 30, that we should definitely ignite your mind and we should all become entrepreneurs in space field. Thank you.
Thank you. Thank you very much, sir.
Any questions are there? You can ask.
Talking about the students to get the opportunity in the academic project related to the space.
Yes, sir.
Please suggest what kind of projects possible by the students.
Yeah, there are many satellite especially is a very complex satellite technology. So what we do is we divide the satellite into thousands of parts. It can be divided into thousands of parts. Especially structure becomes one project for mechanical team. And communication related becomes one pair missing for communication team. Communication itself again 3-4 things will be required. Receiver. For computer science, they have to develop the programs, software for mission control as well as dynamics, flight dynamics related things. And they also have to develop the software for if they are very good and have a passion in embedded systems, they can develop software for the processors which are used in all these subsystems. So many opportunities. If you see, all the 4 streams of engineering branches are being pulled in our activities.
Thank you, sir. Thank you so much, sir. I would like to present the so sir actually pointed out the need of space education for students can involve and the student satellite program to be initiated on the universities, and he also given the ideas for technology. Thank you so much, sir, for your information in the series. I would like to request Dr. English Scholar, to take your decision.
Thank you so much, sir. The GSLV model is designed by our students and printed at the satellite center, sir.
Oh, I see. Okay. I see.
3D printed. Sir, that is
No.
Yeah.
Sir, my doubt is you talked about clean rooms, right?
Yes.
So what is the complication if a satellite is built like outside the clean room? What are the complications are you?
Okay, very good question. See, satellite is a very sensitive electronics. And especially when we talk about optic payloads, little more critical clean room will be required. Like our astrosat, if you see, we had a class 100 clean room, sorry, class 1000 clean room, where the dust particle, whatever I told, 1 lakh, that also is not acceptable. So similarly here, what happens is when we are testing, it is a quite a long time building activity. Satellite is not a short time building activity. So we need to build that. When we are building it, it should be built in a clean environment. So there should not be any uncertainty of building itself or during fabrication itself. So because of that, even if you see the fabrication areas where they do their transfer of technology to industries, all the industries have established ISRO qualified laboratories. And it is being audited by our quality and reliability group every 6 months once or so, to see that our products which is being manufactured should undergo proper environmental conditions. So environmental condition plays a very important role. Like ESD, it's a slow poison type of thing. We don't know if you would have touched unknowingly or you would have missed something. In our excitement, we would have done some thing, but that will not fail instantaneously. It will fail very slowly. Such things have happened and it will become a fatal for the mission itself. So why to avoid, why to take unnecessary risks? We need to go for a good environmental practice to see that all that uncertainties are removed in the testing stages.
So what if the part is created outside this clean room,
yeah,
but we need to implement the satellite in the orbit. So what will be the step which they will take after creating the satellite outside the clean room, if there is any possibility?
No, when they take it out also, you put it in a clean container.
So there is
No question of this thing. Even if you see at the launch pad, the startup companies which you come, there you will be allocated a clean room only. Though it is a CubeSat or small satellite, still you will be in the clean room. So that's why one of our friend also gives a very good lecture, classroom to clean room. So how student when he comes to space, he will be set his mind to work in the clean environment, because we don't want to take any chance in any of our flight because it cannot be repaired,
Yes.
in space.
Thank you, sir.
Hello.
Good afternoon to all. Today's afternoon second session is built by Sri Loganathan Muthuswamy, Mission Director at Graha Space, former Deputy Project Director ISRO Bangalore. Sir will speak about the empowering nano satellites. Sri M. Loganathan, a retired ISRO scientist, served for 36 years since 1973 after completing his master's in applied electronics from PST College of Technology. He contributed significantly to various aspects of space program, including ground segment satellite broadcasting and surveillance camera setup for the first SLV launch pad. As part of the mission group, he participated in scenario testing in Indian IMSAT-2 satellite and contributed in IRS remote sensing missions. He played a key role in mission planning, simulation, and operational documentation for both IMSAT and IRS satellites. Sri Loganathan designed a modern satellite control station at ISAC and contributed to the Chandrayaan-1 mission. Post-retirement, he engaged in nano-satellite development missions like StratSat and SRM-SAT, while also publishing papers and missions to the moon, intersatellite communication and space docking. His interest in nanosat novel missions, mission planning, AI, export systems and automation. On behalf of Dr.MGR Education and Research Institute, we welcome you, sir.
Respected Vasaram sir, other faculties and delegates and students. As such, my slides may not be so attractive or this way. I have brought in the satellites and I am going to talk about what was my past experience in building satellites with students. So I have brought in some of the incidences, whatever happened there, to just show you that yes, how students are involved in that. Space. Hello. A boundless three-dimensional extension in which objects and elements occur and have relative position and direction. That is what I see in space. Space science means that encompasses all of the scientific disciplines that is a multidisciplinary science that involves space exploration, study natural phenomena and physical bodies occurring in outer space such as space medicine and physiology. So this is not space science and space system. No. That science includes generation of scientific generation of scientific knowledge, sparking youth's interest in science, the diffusion of innovation and the creation of markets, the inspiration of people around the world, and agreements forged between the countries engaged in the exploration. So that is what actually the space science means. Yeah. Next. 5 projects I am going to talk about. 2 realized, that is StuttSat 1 and SRMSat 1. 3 case studies, StuttSat 2, SRMSat 2 and SRMSat 3. So whatever the experience I had with the students, how I can do that one, I am going to do next one. No, this is not. StuttSat, in fact, actually, after listening to one of the resource scientist lectures, 3 of the students from INNOVATORS felt it that why not we also do some small satellites. In fact, actually, it is Anne Pavli who has introduced the CubeSat concept, telling that why not students work on the spacecraft. So that is how actually the CubeSat started. So these 3 students or 4 students, 3 or more students thought about it, why not we do it. So they approached the management, as Mr. Vasaram was telling, Shetty. He was actually vice chancellor before the Bangalore University. They approached that actually we want to do something. But the institution was not having that much of funds to really support it. Instead, what they did was they reached about 7 colleges, even one in Hyderabad. and talked to the principal concerned, made them to really realize that or impress them so that they will do a satellite. So it was a consortium of 7 institutions, and almost indirectly each institution concentrating on each subsystem of it. In fact, actually a satellite is a multidisciplinary activities which gives you real actually the management of time and coordination of all the engineering, including physics. That is what actually I have realized there in SRM side also, in STUD side also. So these students actually 7 colleges involved and then started building at the small, that time they call it as not few packets. So that was actually, what is that was establishing interscientific communication. No, that was the second one. Proving improved temporal resolution. That is the second, STUD 2. But next time. No. Student satellite is a microsatellite conceptualized designed by the undergraduate students under the guidance of the specialized organization. A consortium was formed by 7 engineering colleges across South India with native energy as the lead institute. The primary objective of this project was to provide hands-on experience on the design, fabrication and realization of the space mission at minimum cost. So that was actually the idea. The students really driven that motivation to the other institutions and they brought the students almost about 40 or 45 students, which are, they are actually spread about 35 kilometers, some are 50 kilometers away, but actually they were brought into the retained energy. Retained energy supported them to stay there overnight on Saturdays, Sundays, so that they can work. Like that it was paid. Next. Team SUDSTAT has made great achievements like team has been entitled to the international award, the hands-on Bulldog Best Team Award 2008 at the time. At the 59th International Astronautical Congress, Glasgow, Scotland, UK, by the International Astronautical Federation, the team has won many awards for the best paper presentation of engineering science in space. All these things have come after realizing the satellite. Next slide. This is actually the portfolio of the STUDSAT 1. Totally indigenous development, except the solar cells which were actually borrowed from ISRO or supported by the ISRO. You know that the camera, it was actually a local camera. One of the camera they took it out. They made the lens in Surat. They went all the way there, some optical fellows, because the diamond cutting tools they have. So from that angle, they have actually really built the lens for it. And in that actually they understood what is the real optics of space. So because it is going to fly at 600 kilometers and you have to take an image of it. So what is the focus and focal length and other things. Similarly, they have built the solar cells with support of ISRO, and then the other electronics. The onboard computer was made, the control was magnetic control, and then the program was actually done. Unfortunately, the flight software, they programmed it for a particular altitude, 600 kilometers. But the launchers never put them in the right place. Exactly, you can't expect it. So, just a small variation of 50 kilometers, their software, they automated such that actually after that so much time, the camera should be made on. Unfortunately, because of the height, there is a slope, so it's making it on the ocean rather than on the land. So due to that, actually this mission has failed. Otherwise, the real experiences students gained was wonderful. And you know what they have actually, about 12 students of STUDSAT 1 especially the senior 4 fellows, were immediately absorbed in Delphi, and other 3 fellows went for space program in Germany and Lisa. So that is what actually the real knowledge they gain out of this experience. And then other thing is teamwork. How they really work together to realize an event. That is what actually they have learned. And that instead of that time there was no industry to observe them, but there other institutions there who have really recognized their knowledge and accepted it. Today, the girl, one of the girl, she is actually a PhD student now, employed in a very high satellite industry in Canada. This man, the first fellow who has actually started the dialogue, he is now actually manager in the space industry. So like that, it was actually they went. Now, then we went to the Stuttgart 2. Stuttgart 2, that first slide. No, 3 sets back. No, that's primary objective. Back. Okay. Next slide. Actually, the purpose of that tool was we want to establish inter-satellite link. So what we tried was actually on 60 gigahertz, it was really spectrum available. We want to use it for inter-satellite link. So 2 global satellites jointly will be launched and separated. And then we actually, the separation will keep on increasing, and we want to test the inter-satellite link for that. So that was actually the main purpose. And then additionally, to have the better temporal resolution, so that we will visit the place temporarily quickly. So that was actually the idea for this Stuttgart 2 program, and that is actually the team. Some of the Germans visited the energy institution, and the students who are involved in that actually shown me. Yeah. Next. Here is the activities where in Stuttgart 2 went on. In fact, actually this is the part of this inside the clean room, where actually one of the students is explaining one of the electrical systems developed there and then it kept there. And that is actually the team, the main team, which is involved team at the NSBT or the conference and that. Then the presentation at BTU welcome. The first, this one is actually on the 65 yards international clean gym. They were presented a paper on that. So these two, one of the girl and the other one, this girl actually of course established a very good this one on orbital mechanics. She is very shrewd in that. She picked up. Today she is there in US, and the PhD guy insisted on her to go for a 4-body problem solving. She wanted to avoid it, but he said, James, no, you work on that one, you can do that one. So she is at the tail end of it. So 4-body problems she is working on, this girl. Of course, now they got married, and he is there in States in another university. He has completed his PhD and doing well. Actually, this is the first these are the Stuttgart conference. Actually, that 60 years program was given to the defense also, because in the defense camp, they want to have a short link communication which should not be interrupted or it should not be. So that to avoid that one, we actually proposed it to DRDO also. Unfortunately, we could not get through that. That was actually with the director, Shivakumar. And this is the team. Berlin Space Technologies head. So these are all some of the activities which went through in the Stuttgart 2. Now what I want to tell you is the complete team development. Only I was actually a person sitting there. No other thing actually, but the students have come together. We have a lab. In the lab only, as Professor Vasantha was telling, I always go at 5 o'clock. And I will be there after 10 o'clock, even in Bangalore. In SRM, it's a different issue. So, here, and what happens was, some of the things, when the classes are half a day from Tumkur, which is about 45 kilometers or so, students come here for the real project point of view. Of course, they will stay overnight. They come here and the evening they start working and they will go. Normally, I will go very late to home. So that way only we were working. So no college times are used. And another thing is, most of the students, all their curriculum activities are not at all a serious issue for them. Most of them are more than 8.5. So they have their assignments, everything is, time management is very good with them. Apart from that, and then they stand very well in this project work also. So that is how actually we were doing, and teamwork, because see, you have to make the structure, but you have to really get the CG. Then mass distribution into the structure is very essential for to get your CG, as well as moment of inertia calculations. And one thing that normally I will tell is, first thing you should know is the basic fundamental units and measurements. Without understanding that and see, you should know what is millimeter. Then only you can adjust, especially for a small satellite like this, your CG as well as your inertia measurements. The inertia measurements really in the rotational dynamics needs. So that should be balanced very nicely in the individual axis. So that way we want actually the fundamentals. Communication side, yes, definitely you should know. Actually we should know what is dB, what is dBm. These differences you should know, then only you can really work on the communication system. People have worked on patch antennas. Really they came out with a very good patch antennas and it was actually tested. One good thing with the institution is the department support in testing the systems. See, communication point of view, they provide the HFSS facility and the signal generators. So those things actually can be easily available and the students can work on together. Especially again, they permit it after 5 hours, 5 o'clock. So that was the support which is given, and students are really very much interested in doing it. So we went through. Unfortunately, we gave the PDF, and after that, actually from ISRO, we could not get the signal to go for it. At that time, at 2010 time, second satellite from an institution is not really accepted quickly. They ask for money for launch. So first satellite is free, but second satellite they can claim some money. So that way it was got delayed. And then further the 7 institutions reduced to 3 institutions, the funding problem started coming. So that way it was. But again, another technology what we introduced was again solar sail. How to really get back my satellite with solar sail. That was also design was made and then period was given. Getting late? Time, huh? Okay. Go to the other one. SRM sat This one actually was launched in the DSWC 18. This is the one which I got there. The next slide. It is a spectrometer payload, August payload it is actually. And then it was totally, the antennas were designed. The other black one is actually the spiral. The spiral antenna was actually fabricated in here in what do you call it? Hindi. It was a petty shop. The fellow knows how to really make the coil. So the students I made the students to give the dimension of the coil, pitch of the this diameter as well as the pitch. We made it. Otherwise we made it and we used it to avoid this yes. Next one. Okay, let me complete it. This is what actually the internal structure of the SR satellite. The total aluminum frame was fabricated by the students at the in fact, the industry, one of the persons said, I will give you the even aluminum, total block was giving it, and then actually totally free of cost. And then he allowed you work on this one CNC machines, but only thing is power is available only in the night because Chennai power shortage is there for the industry, so they go at night 1 o'clock and use the machine and then fabricate the statue. Here is actually the main board and then the other is actually, just go to the next slide. Here what I used is actually the arm-7 board, which is actually a development board, which we really fabricated because we made 3 boards. Somehow or other, it was made in Bangalore, but somehow or other, either the memory problem was there or the computer microprocessor problem was there. So instead we decided that why not we directly use the ARM7. So ARM7 board was used and was actually inserted into that one. And then actually we used the Texas transceivers for both communications. Yeah, next one. This is where actually students, actually as you see in the other one, how they work here, and it is actually the Arduino board or something, which they really tested. Next one. This is our lab, SRM lab. This is how actually the students work in the unit. That sofa is there, another sofa where it is taken from there, no? That is the real night bed for the students. Normally they sleep there. Overnight, make the students will sleep here, including one of the girl. Shamo, she manages the watchman, saying that I have come to the hospital, so she will sleep also here. So that much interest was developed, and then actually the internal team discussions are very fine, especially when the lab was arranged. Okay. And of course, how did I be selected? And so initially we just floated that we are interested in taking the students. Thousands of students have come. 4 classrooms were used to examine them. After that, we had to take it out, and then actually the second level students will make the interview, and the last final interview I will be making and then taking the students. So in that way, the students are coming. Most of the students are actually all good grade students, and they find value. In fact, actually, out of this SRM Center 1, 12 students were there in America. One of the fellow was in MIT. And one of the incident I tell you, 10 o'clock, he somehow same bloke in the class fellow. This fellow was working on solar panels. 10 o'clock he came and then he asked for some doubt about it. At 11 o'clock he is coming, sir, same bloke is calling me. He is asking me to report at that hotel. That's 12 o'clock. That's all. I was asking him, what happened, man? You need one day at least to take all your clearance certificates from the college. No, sir. He said he will not give you the job, so he wants to really go. That is how they were on hot cakes. Another fellow who worked on the control system, who knows MATLAB, he was taken in Mahindra. And there were about 5 MTech students, and this fellow is a BE student. You know what is the management suggest? Take advice from advisory team, consultant, discuss with him, and then only you do it. because he was very thorough with math lab. Communication side again. I will next one. This is actually another this one. Yeah. So here is actually the orbital definition. Carry on. Next one. This is actually the PCB which was actually designed by the students, was made. So everything was done by students. So it's a hands-on experience. Next. This one, and we went for a conference in VTU at Restaurant Bellow. Then actually the satellite components were on display. See, that is actually the main PCB. These are the coils wound by the students, and that is actually the top plate right there. So next step. Okay. Yeah, I got it. So this is the coil and the PCB. Next step. This is what actually the structure made in Bindi. And top plate, side plates, and even the frame. Now, this is the interesting thing is actually, this was the FEM analysis made by third semester students, mechanical engineering. Fourth semester, they completed the analysis, FEM analysis. And then when it was taken to the ISRO for testing, acceptance tests were only from the payload side, but as far as the qualification test was done on the other two sides. And in the first, see, the previous satellite was actually IIT Kanpur, which has failed. So they said, no, yours also you can collect your accept goals. But actually on the first shot it went through SRM. So really people were surprised, astonishing. How come actually, I would like to see the document and then how the design and all. This is how actually see we saw. And then another thing is actually, I made the students to write the launcher interface to understand what is the real interface coming into the satellites. So from that angle, you see that's what I see. So just show you that. Yeah. Now, 25 students were taken to Sririkota. I got the permission. 4 students at a time will go to the tower top where the satellite. So this is actually the satellite mount. These are some of our students. Next slide. Go. So 4 students at a time they listed the launcher. This is what actually SRM sat real coverage area in a this one. This is a completely inclination orbit. Yeah, next. This is what it is. 867 kilometers. Now, this is actually the SRM data which is coming, beacon data. These are all the parameters which is normally coming. No, sorry, these are orbital parameters. Next one. These are actually what we do tracking. So this was actually one of the orbit passing just almost close overhead. Okay, this is what actually. Next one. This is our ground station. This is our ground station. Next. This is the antenna for 2 beacon as well as for the UHF. This is the team. So it's almost like see from the second year onwards to 4th year, all different departments are involved. This is the total team involved in the Dr. Ramakrishnan is here, who chairman who visited there at the time it was taken on. Next slide. Oh, this is myself. These are all my part of funding students, which I really would like to share. Yeah. Next slide. This is what I see. The last Shashi Padda is the fellow who designed this, and he assigned individual names. And among them, actually, there are one fellow called, that's what it is, many of the students. See the Buddha, bottom down, he went for internship in Japan. And after going there, the person was impressed. He said, no, you have to do MS program. So then he started doing MS program. After that, he insisted that he should do PhD program. So that is how actually the empowerment was given to them. Another fellow who is actually now global, you see, one is actually the ground station fellow, the other fellow is on the communication side. The ground station fellow is now Dhruva Space CEO, who is actually the, okay. And this is actually, this one actually, this is my design on a multi-satellite display center. So this is how actually I designed that one for the ISAC. Okay, and all the systems are 385 system and then Linux based. I didn't use any Windows or anything, and 385. So all those things are actually established, and then I will show a pictorial information rather than the real data. Suppose the terminal in the tank terminal capacitance, wherever that location is there, I will give, and then I will give the color signals such that immediately you can make it out. And when it is coming to red, no question of alarming, but at least the red indicates you that yes, it is going beyond. So such displays actually I was making it. So all these three displays are actually for that. So initially for the INSAT 2A, this was actually display was made and ready and was used. Next. Launched about 16 PDR for submitted to SO. Second question of space hackathon related to 17 papers published related to SRM Set 2, 3 papers published related to SRM Set 3. Yeah. Now, in fact, actually SRM Set 2. The second set of students, I started from the second semester because when they are coming from the PUC, they have the real STEM fully filled up. Second year once ago, they get entertained into the curriculum other activities, social activities and also they will not be available to me. So I started involving the second semester students. Then that is the full team this is after realizing. This is actually the mission to moon PDR, not baseline. Baseline is another one, but this is a PDR submitted to ISRO for launch. Dr. Kiran, actually my colleague in SAT, actually in fact after seeing that one and he was a photographer. So he said, Loga, see now I may be your friend, but I cannot, I have a department. So I have to release into 2 departments. So accordingly it was going on and on and on, but could not do. Once the other next chapter came, I gave it to telling that whether I can put a piggyback on Aditya, from Aditya whether I can go. So that is how actually we planned, and this document was made. By the students, the complete list of students who are really working on the mission to moon. So that is there actually. So that was actually what I induced to the students was kindly understand the technologies and what is the real multidisciplinary system there. Understand the basics. Understand what is it now. I wanted to have a novel technology in 2013. Mission to moon. So they studied the orbits and the different orbitals. Next one. These are the papers after the PDR. Students have published. Most of the AIA and IDT and this one. These are actually mission cases. Recent drivers. What are the recent? This is actually the L1. We want to go to L1. From L1 we jump to moon. So this is what actually directly when they are showing the scope, that they want to see direct L2 or L1. That is the actually. These are all actually stable and unstable variables where once you put the satellite into that one, it will take but it will be long time. So all these studies were made by the students and I induced them to do it. They even study the moon surface where to really go for it. So that understanding was there fully. Yeah, next slide. This is actually a small propulsion system with the liquid actually 290 gram propellant mass 90 grams, so but it's a for the mission is not useful for the lower orbital corrections we can do. But there is actually another orbit delta V budget how they calculated for that from home mission point of view. These are all different. This is SDK. This is all actually SDK generated graphs. So people really understood SDK and they started off. That was actually the yellow is the sunlit area and the red one is the shadow area. So that is how it actually started. Next.
Sir, excuse me, sir. Actually,
So this is what these are the two students in VTU where they have actually worked on SR. Next one. Next one. This is what actually the configuration of the 72, that is Chandrayaan moon mission. That is the model to get there. Next. This is the total configuration. This is what actually the moon mission is. Here is there. SR3 we want to have a docking. So from docking point of view, especially I want to have a space lab, a small future space lab, where we can do some experiment and translate and bring it back. For that actually we can. Some of the concepts they have developed on the table actually we started working on it. Very sensors. Next. These are all actually some of the models made by the students. Next. That is how actually you go for locking. Some of the mechanics they have drawn sequence here. These are all actually fabricated. Actually, the students are fabricated. See that they really getting locked and down. Next one, this is the thing. Okay? Yeah. This is the thing. Detection.
Thank you, sir. Sir, pointed out his past experience and based on the team. SAT 1, SAT 2, and SAT 1 and 2, and some brief how they are manufacturing it, and how the teamwork made the structure and all. Now I invite Dr. Vishwanathan sir to honor the Sri Loganathan sir. Thank you, sir. Now the first session is over. Thank you.
Thank you so much, sir. Actually, sir, while starting, you said your slides are not impressive, but we would like to say that your slides are certainly impressive and inspiring. Thank you so much, sir. We would like to honor Chair and Co-Chairperson of the Session 1. Sir, and ma'am, please.
Good afternoon to all. So we are going to start the session 2.
There is a small break, a tea break for 5 minutes. We request the delegates to be present after 5 minutes sharp. Refreshments are served outside the auditorium.
கேமரா எடுத்துற கேபிள்லாம் பிடிக்கும் கேபிள்லாம் பிடிக்கும் வேணாமா கேபிள்லாம் பிடிக்கும் கேமரா எடுத்துக்கணும்
Amit University students, are you here? Can you put up your hands? Amit University students.
மாற்றி கனெக்ட் பண்ணுறீங்களா?
இல்லைங்க, அங்கே மைக் ஆஃப் ஆன் பண்ணி வச்சுக்கோங்க. இதுக்கு அதுக்கு நான் சம்மந்தம் இருக்குது. இதுக்கு அதுக்கு நான் சம்மந்தம் இருக்குது.
நம்ம டீம் பார்ட்டிசிபேட்ஸ் உள்ள கொண்டு வாங்க. ஏன் பார்ட்டிசிபேட்ஸ் உள்ள கூட்டிட்டு வாங்க. உள்ள கூட்டிட்டு உட்கார வை.
ஆன்லைன் கொஞ்சம்